Hey, Preetam, grab your headphones. It's story time. Welcome to this deep, immersive audio journey through a brief history of intelligence by Max Bennett. We're going way back, billions of years back, to uncover how brains evolved, why we're smart the way we are, and what that tells us about the future of AI. This isn't just facts, it's an epic tale of tiny worms, fish learning tricks, rats dreaming up futures, chimps playing mind games, and humans inventing words to share it all. Let's dive in. The big question Max starts with is simple but mind-blowing. How can AI crush world champions at chess or Go, solve protein folding that stumped scientists for decades, yet completely fail at something a toddler can do, like loading a dishwasher without smashing plates? The answer, Bennett says, isn't more compute or bigger models alone. It's that we've only reverse-engineered parts of biological intelligence. To get truly flexible, common-sense, embodied smarts, we need to look at the full evolutionary playbook. Bennett frames the whole story around 5 major breakthroughs, like pivotal software updates that evolution stumbled upon over hundreds of millions of years. Each one built on the previous, adding new ways to learn from the world, imagine it, understand others, and share ideas. And amazingly, modern AI has copied some of these almost perfectly, while totally missing others. Breakthrough 1. Steering and Valence, the birth of brains, around 600 million years ago. Picture the Ediacaran Seas just before the Cambrian explosion. Life is mostly simple blobs drifting or sitting still. Then come the first bilaterians, tiny worm-like animals with front and back ends, mouth here, tail there, and a little knot of neurons at the front, the proto-brain. The killer innovation? Steering. No more random drifting. Now they could sense chemicals or light and actively turn toward food or away from danger. This introduced valence. The world gets labeled good or bad, approach or avoid. Early neurotransmitters like dopamine and serotonin started as navigation signals. Dopamine says, "This way is promising." Serotonin modulates caution. Even our deepest emotions, desire, fear, disgust, trace roots here. They're ancient guidance systems for moving through space. Think of C. elegans, that famous nematode with exactly 302 neurons. It navigates gradients like a pro. In AI, this is the basic reward signal in reinforcement learning. Positive reward, go that way. Punishment, avoid. But biology did it embodied in a real physics-bound body with tiny energy. Without breakthrough 1, nothing matters. No point learning or planning if you can't even move toward goals. Breakthrough 2, reinforcing, trial and error learning, about 500 million years ago. Enter the first vertebrates, jawless fish swimming ancient oceans. They added something revolutionary, the ability to learn from consequences, not just react instinctively. The basal ganglia and dopamine circuits evolved to do temporal difference learning, predict rewards, update when reality surprises you. Dopamine neurons fire not just for reward, but for better than expected. Schultz's experiments show this crystal clear. This let fish try new hunting moves, remember what worked, abandoned what didn't, all without genetic rewiring. Bennett points out this is exactly what Sutton and Bartow formalized in the 1980s and 90s as reinforcement learning. AlphaGo, DeepMind's game crushers, they're using fish-invented algorithms from 500 million years ago. Biology's version is insanely efficient, lifelong learning on sparse data, no catastrophic forgetting, all in a low-power wet computer. Examples everywhere. Goldfish mastering mazes, lizards tweaking predation strategies. AI still struggles with sample efficiency and stability. Biotricks like dopamine-style curiosity could fix that. Breakthrough 3. Simulating, imagination and mental replay about 200 million years ago. Mammals arrive with the neocortex and a beefed-up hippocampus. The game changer, vicarious trial and error. Try things in your head first. Hippocampal place cells and grid cells build spatial maps. During sleep or rest, they replay sequences as if the animal is moving again. Rats mentally test maze paths before risking it. Squirrels simulate nut hiding spots. This unlocked imagination, planning, episodic memory, like, remember that time? Counterfactuals, what if I'd turned left? Even regret. The neocortex runs predictive models, always guessing what's next, minimizing surprise. Predictive coding theories from Friston and others. AI is chasing this with world models. Mu0 simulates board games internally. Diffusion models dream up images or videos. But mammal simulation is grounded, tied to body sensations, emotions, physics, and learns from handfuls of examples, not billions. Bennett says this is why mammals outlived dinosaurs, better at anticipating disasters in volatile worlds. Breakthrough 4. Mentalizing, modeling other minds, about 60 to 30 million years ago. Primates take simulation deeper, not just your own actions, but other agents' minds. Theory of mind, understanding beliefs, intentions, deception, cooperation. Chimps fake throws to mislead rivals. Baboons forge alliances. Monkeys track who's dominant. This exploded social intelligence, empathy, politics, culture precursors. Builds on Breakthrough 3, simulate someone else's simulation. LLMs fake this in chat, predict what a person might believe or say, but it's pattern matching, not grounded understanding from real social bodies and emotions. Biology gets multimodal cues, gaze, posture, pheromones, tone. Breakthrough 5, speaking, language and cumulative culture, about 300,000 to 50,000 years ago. Humans add the final layer, symbolic compositional language. Not just grunts, grammar, recursion, displacement. Talk about things not here or now. We share mental simulations across brains, teach skills, plan hunts, build myths, write books. This creates cumulative culture. Each generation stands on giants' shoulders. LLMs are Breakthrough 5 on steroids, trained on humanity's entire text output, masters of symbols and composition. But they hallucinate, lack physics intuition, struggle with true social nuance because no embodied valence, RL grounding, simulation, or mentalizing from prior layers. So, what does all this mean for the future? Bennett's hopeful. The brain's evolutionary hacks are a roadmap. Next AI needs hierarchical world models with offline replay, dopamine-like intrinsic motivation, grounded social simulators, stable lifelong learning. Not copy biology pixel for pixel, but steal the clever shortcuts that made intelligence efficient, adaptable, and truly smart. From worm steering to human poetry, it's one long chain of innovations. Pretty incredible when you think about it, right, Preetam? The journey from single cells reacting to now us chatting about it with machines that echo those ancient tricks. Thanks for listening all the way through, buddy. Which breakthrough blew your mind most? The rat imagination part, or how language turbocharged everything? Hit me back. I'm all ears.